on FRQ 329. This is a great question too. It has the mean value theorem in it. And I told you to print that cheat sheet. I'm starting to get like 4 or 5 sheets that I think you should have handy. And basically it's to help you word stuff right if it comes up. And this is intermediate value theorem, mean value theorem, and extreme value theorem cheat sheet. So you'll see that the mean value theorem is going to come up, and hopefully you'll learn to recognize it. Okay, so let's look at the question. We got hot water dripping through a coffee maker, filling a cup with coffee. So this is how much coffee's in the cup at time for minutes. So that's the data. Now A says use the data in the table to approximate C prime of 3.5. Show the computations that led to your answer and indicate units of measure. All right, here we go with the same scenario. It's asking for the derivative at a point, right? And so you can't do that with data. You only can do an estimate of the average rate of change. So A, you would say, they asked for exactly C prime of 3.5, so you'd get that right back, is approximately equal to average rate of change, which is C of 4. You would go to the one above it and the one below it. So C of 4 minus C of 3 over 4 minus 3. Now this is a no calculator, so they gave you some easy math to do. So that's approximately equal to 12.8 minus 11.2. So that's approximately equal to 1.6. Now get the units. It's a rate. Ounces of coffee, right? Per, you can put it like that, per minute. Okay, I had enough room for it that way. All right, so how do you get your points for this? This is worth 2 points. You get 1 point for the approximation, 1.6, and 1 point for the unit. So they gave you a point for the correct units there. Well, let's go on to B. B says, is there a time t, okay, between 2 and 4 where the derivative is equal to 2? All right, so we're saying, hey, is there a time where the slope is 2 between 2 and 4? And so if you can find, okay, so let me try to explain this. And by the way, it says, is there a time? And that's a hint, right? So we have some function, and let's just draw it like this, right? And let's say that they want to know, is there a time when the slope is 2? When the slope is 2, meaning at some time t is the slope 2. So like, is this 2? And at this time, is this slope 2? And how you do that is you find that if you have a point here and a point here, and the average rate of change is 2 between those 2 points, then there has to be somewhere where that's equal to it, okay, by the intermediate value theorem. So, the mean value theorem. All right, so MVT. Okay, so let's talk about that. So, we would say, you just would start with, remember, if you look on your cheat sheet, it says if f of x is continuous on the closed interval and differentiable on the open. So you would just start that right from your cheat sheet. Because you can, don't say if, because you're proving this, right? So because, and let's use the right function, c of t is continuous. Well, it doesn't say it's continuous. It says it's differentiable. So let's back up and say is differentiable on from 0 to 6. Says It's given by a different way or two dimensions. So differentiable, and so we would say it can't be the endpoints, right? Some 0, 6. And then say, and therefore continuous, because differentiable implies continuity. Continuity doesn't imply differentiability, but differentiability implies continuity. So continuous on closed interval 0, 6. Okay? Then there must exist at least one value C in 0, 6 such that, okay, and so then you would say F of, C of 4 minus C of 2 I messed that up with the C. C of 2 over 4 minus 2 is equal to 12.8 minus 8.8 over 2, which is equal to 2, which equals F prime of 2. Equals 2. Okay, because it's differentiable and continuous, then there must exist at least one value C in 0 such that the average rate of change, which is equal to 2, is equal to C prime of T. Notice this right here. I'm going to circle this in green. Right? You did it. It's the other way around. We said 2 equals C prime of T because we're putting these two steps together. All right, so that would be part B, mean value theorem. And you have the nice cheat sheet to write it out exactly how it should be. This was worth 2 points. You would get 1 point for doing this average rate of change and 1 point for the MVT. Let's go on to C. So C says use a midpoint sum. Okay, midpoint. 3 subintervals, equal length to approximate, check it out. It's the average value. Use correct units, explain what the meaning of is in the context of the problem. And we know that 1 over 6 and then the integral of the derivative is the average value. Okay, so here we go. Okay. So we would say that the 1 to 6 of 0 to 6 of CT dt is equal to okay, midpoint. So let's do the midpoint. So we want 3 subintervals. So here to here is 1 with 1 in the middle, and then 2 to 4, and then 4 to 6. So each one of these are 2. And the midpoint would be the 1, the 3, and the 5. So it's just equal to, don't forget your 1/6, times 2 times 5.3 plus 11.2 plus 13.8. And so that would be, you get, and you have to do it by hand. So that would be 1/3 times, and then add this 5.3, 11.2, 13.8. That's 3, 5, 6, 7, 8, 9, 10. And you get 30.3. And if you divide that by 3, you get 1.01. So we have approximately 1.01, and we are trying to get the average, and it's the average temperature, so you would say, or the average amount, ounces. It's not a rate, okay? And so what does it mean? This means that the average amount of coffee in the cup between 0 and 6 minutes is 1.01 ounces. So you get 3 points for this. You get 1 point for the midpoint sum. You get 1 point for 1.01, and you get 1 point for saying it's the average amount. All right, going on to Part D. Part D says the amount of coffee is modeled by this function. The amount of coffee is modeled by that function. Using the model, find the rate, okay, that's the derivative, by which the amount of coffee is changing when t equals 5. So basically, isn't it asking us for b prime of 5? Yes, it is. So then we want b prime of t. So we have to take the derivative of this. So this would be no calculator, so it would be 0 minus, and then we bring the 0.04 down in front. Depends on how you want to do it, but the derivative of 16e to the negative 0.4t is 16e to the negative 0.4t times 0.4. So that would be minus to the negative, right? Yeah, so negative 0.4. So you end up with a plus 16 times 0.4 e to the negative 0.4t. So that is 16 times 0.4 is 6.4 e to the negative 0.4t. So that's b prime of t. And so b prime of 5 would be 6.4 e to the negative 2t. And, 2 times 5, right? No, the t was 5, so no t to the negative 2. So it equals 6.5 over e squared. And, or 6.4. I don't know why I wrote 6.5 back there, guys. 6.4. So that's 6.4 over e squared. Now let's put our units down. That's a rate, so it's ounces per minute. Okay, it doesn't ask what that was, so you just have to find it. All right, so let's do the points for this one. This was worth 2 points. You get 1 point for b prime of t being right. So 1 point for b prime of t and 1 point for the answer. So that's 2, 5, 7, 9. There you go. That's FRQ 329.